projection. Sheet 5 is the principle of orthographic projection. So what is meant by ortho? Anyone know what is meant by term ortho? Ortho. O-R-T-H-O. Anyone know what is meant by the term ortho? Graphic is nothing but the representation. And projection. What is meant by projection? And what is the principle of projection? Ortho. So have you seen orthopedic? They will say few doctors as orthopedics and all those things. So ortho is nothing but the 90 degrees. Ortho is nothing but the 90 degrees. So if there is any object, suppose in your class there is a projector. So what happens is, this is my board. So this is your drawing board. In the drawing board, I will be placing the projector screen. This is my screen, projector screen. I will drag it down, and at the top you have a projector. At the top you have a projector. From this projector, a light will pass. From this projector, a light will pass, and it will project whatever I am projecting. It will project. So in the projection also, what we do is, there is an object. There is an object which needs to be projected. So if I pass a light at a 90 degrees, so 90 degrees, this object will again replicate at the back. Okay, this object, same way it will replicate at the back. Okay. Suppose this is a rectangle. Suppose this is a rectangle. Suppose this is a rectangle and has the parts of A. Example, this rectangle has ABCD. ABCD. So now on this rectangle, I am passing a light, and this light, it will follow a shadow on the wall, and it will show the same object, ABCD. Okay. So this is the orthographic projection. It will be at 90 degrees. If you are projecting anything at a 90 degrees, it is called as orthographic projection. Okay. So generally, all the objects, whatever we see, all the objects, whatever we draw on Indian drawing, it is a two-dimensional, because your drawing sheet is a two-dimensional, and that's two-dimensional. But generally, the objects are three-dimensional, length, width, and thickness. But your drawing sheet only two. So in order to represent a three-dimensional to two-dimensional, we use the orthographic projection. This orthographic projection will be based on the principle of projection. What are the principle I have explained earlier? Same principle. What the principle is? Straight lines are drawn from the various points of the object. Suppose I have a triangle. Triangle only has ABC. So only this ABC will be projected on the other side. On the projector, it will project. Okay. On that plane, I need to have a plane at the back side. I need to have a plane at the back side. On that plane, on your projector sheet in your class, you have a projector sheet. So on the projector sheet, it will project. Whatever the shape is, the shape will be projected. Okay. And you will generate the points. So if this is the I'm projecting, I'll generate the points. If I join all the points, then I can generate the object. Final object I can generate. Same replica of the object I can generate on the projector. Okay, that is called the projection of the object. Okay, and the lines. So what are the lines are joining the object? Those are called projectors. These are called projectors lines. Okay, and this is called projection of the object. Whatever the object is created on the back side of the plane, it is called projection of the object, and these lines are called projectors. Okay, then there is a division. This is a division of projection, not orthographic projection. Projection divided two types: perspective and parallel. And perspective has two types: linear and actual. And this
So we have to draw this.
No need. Next, there are perspective are two things: linear and actual. Next, parallel. Parallel divided into three types. One is oblique, axonometric, orthographic. This axonometric divided into isometric. So in the 5th unit, you will find convert an object into isometric to orthographic, and orthographic to isometric will be getting now. Okay. Next is we are discussing about orthographic projection. In this orthographic projection, again divided into 4 types. Divided into 4 types. First one, first angle method, second angle method, third angle method, and fourth angle method. Okay. And out of all these things, we learn only first angle method. Generally, we learn first angle method and third angle method, and we use only first angle method. And isometric, you will be learning in the 5th unit. You will be learning isometric projection. Okay. So it is orthographic projection. This is isometric projection. We will be learning. Okay. Yeah. So whenever the projectors are parallel is nothing but 90 degrees. Whenever there are 90 degrees to each other on the perpendicular plane, it is called orthographic projection. Okay. Whenever it is perpendicular 90 degrees, it is called as orthographic projection. Okay. Okay. So everyone look at the video. I'm stopping the share. So everyone look at the video. So what we do is, this is my book. This is my book. So what I do is, this is my plane. I need to consider the plane. This is my horizontal plane. Whenever the plane is horizontal, this is my horizontal plane. And I consider this as my vertical plane. I consider this as my vertical plane. This is my horizontal plane. So whenever you are making the projection, there are 2 types of plane. One is horizontal plane and another is vertical plane. And if I lift this one, then here the horizontal plane and vertical plane both are touching at the point. The horizontal plane and vertical plane both are touching at the point that is called axis reference plane. On the reference line, both horizontal plane and vertical plane are touching each other. Okay. So there are 2 types of planes. One is horizontal plane and vertical plane. Generally, we consider 2 planes, horizontal plane and vertical planes. And there are different types of planes. We need minimum only 2 planes. We need minimum 2 planes in order to represent an object. So those 2 planes, PLA, MES, are called as, generally we take horizontal plane and vertical plane. Okay. And these 2 reference plane intersect at each other at 90 degrees. So this is my horizontal plane. This is my vertical plane. Okay. If I'm making it as 3D, this is my horizontal plane and this is my vertical plane. These both are intersect at a common point. This point is called reference line. These 2 planes. This is my horizontal plane. I can write it as HP. Horizontal plane, I can write it as HP. And vertical plane, I can write it as VP. Horizontal plane, vertical plane. So here, if I draw any object, this object will project here like this. It will project on horizontal plane and it will project on vertical plane. It will project on vertical plane. Okay. So there are different types of reference planes. One is vertical plane or frontal plane, because if you see the front, this is your vertical plane. This vertical plane is the front of the object. This is the object. This is the front of the object. It is called as a vertical plane, VP, or frontal plane, FP. So we called as VP, vertical plane. This we called as HP. Okay. Next plane is the horizontal plane, HP. This is called horizontal plane. And next one is the profile plane. So profile plane is nothing but, suppose if I want to measure this side. If I want to measure this side. So this is my profile plane, PP we call it as. Nothing but the side view. Suppose this is my object. This is my front view of the object will be projected on the vertical plane. And my bottom or top view of the object is projected on horizontal plane. And my side view, this is my side view. My side view will be projected on profile plane. Okay. Minimum 2 planes are required. One is vertical and horizontal. But if the side view is complicated, then I need to see the side view of an object on the profile plane. Okay. Next, note intersection of BP and HP. So where the BP vertical plane and horizontal plane are touching, that is my XY line. Where my vertical plane and horizontal plane are touching, that is my XY line. I have to write here X, I have to write here Y. Yeah, any doubts? 8, you can, any doubts? 8, roll number 8, unmute and you can ask. Any doubts? Roll number 8. Yeah. So there are total 2 planes. One is vertical plane and horizontal plane. If you want to see the side view, you need to add one more plane called profile plane. Okay. And wherever the VP and HP are touching, that is called XY line, which is called reference line. And intersection of VP, HP, and A.V.P. So wherever the VP is touching, AP is touching. So wherever the VP, HP, and PP profile plane is touching, that is called X1, Y1. This is called X1, Y1. X1, Y1 line. This is X1. This is Y1. That is the line. Okay. So I'll draw once again. So this is your vertical plane, and this is your horizontal plane. So where the vertical line and horizontal plane are touching, that is called XY line. Okay. And similarly, where the vertical plane, horizontal plane, and this line is called as X1 line, and this is the line. This is starting of the line, and the ending of line you have to write Y1 line. Okay. Next, understood the concept or any doubt in this one? If you understand this one, then only you can understand the other concept. And sheet 5 is the most important in the drawing. In the drawing, if you understand sheet 5, then only you can understand next 6, 7, 8, 9, 10, 11, 12. All the sheets you can understand only if you understand sheet 5. So listen carefully. Understood? Any doubts in this one? What is meant by vertical plane, horizontal plane, profile plane? Okay. So if an object, if I want to project an object, I can project upon 6 views, such as top view, bottom view, next front view, rear view, next side view, right hand side view, and left hand side view. Okay, so like this I can see the object at total 6 views. Okay, similarly my front view. So this is my object. For the object, this is my front view, back side is side view. Next, this is my right hand side view, this is my left hand side view. Similarly, top view and bottom view. You have total 6 views of an object, which is, I will also show the image. So this is my object. So the object shows different in different views. Front view and back view almost show the same sign. Bottom view and top view show the same way. And left hand side view, right hand side view show the same. So minimum you require 2 views. Minimum you require 2 views in order to generate a simple object. If it is a complex object, then you require total 3 views. Okay. So if you know the front view and top view, you can generate an object. If it's a simple object, if it's a complex object, you have to know the front view, top view, and either of the side view, left hand side view or right hand side view. Okay. So this is my object. If I see in the front view, I can see this in the front view. I can see this one in the front view. I can see this one in the front view. I can see this one in the front view. Okay. If I see from the top view, I can see this one in my top view. I can see this one in my top view. This part I can see in my top view. Similarly, if I see in the side view, I can see this part. I can see this part. So that is the part projected here. This part and this part is projected here. Okay. If I'm seeing the front view, I can see this part. I can see this part. I can see this part. This part is projected here. Similarly, if I see the top view, this part is projected here. And what are this part? This shape is there. This shape is projected here. Okay. Write down this theory note compulsory in your observation notes. Okay. Whatever I gave the theory notes of unit 5, write down the unit 5 theory notes. So minimum 2 views or 3 views are required for generating a complete object. If you want to generate a complete 3D object on a 2D shape, on the 2D drawing sheet, minimum 2 views or 3 views compulsory you need to require. Okay, while drawing on the drawing sheet. It's in the clockwise. It will rotate in the clockwise direction. Okay, so it is similar to your. So it is similar to your whatever you are learned in the quadrants. How to draw the graph. Similar to this one, you this will be there. So this is your quadrant 1, quadrant 2, quadrant 3, quadrant 4. This we called as the first quadrant, first angle method. First angle method, FAM I'm writing, first angle method. And second one is the second angle method. We called as second angle method. Third is the third angle method. Third quadrant is the third angle method. And fourth one is the fourth angle method. Fourth angle method. Okay. So generally when you're drawing the graph, we consider this as x-plane. So here we don't consider as x-plane. This we consider as letter D. D is nothing but distance from the horizontal plane. This is my horizontal plane. Distance from the horizontal plane, either it will be above or below. Okay. And if you see this one, anything above is positive. Anything above is positive. Anything below the horizontal plane is negative. Negative D. Similarly, this we call as a vertical plane. This we call vertical plane, and this vertical plane is represented by letter H. Represented by letter H, and whenever it is right side to the vertical plane, we consider it as positive H, and whenever it is left side, we consider negative H. H is nothing but distance above or below from the vertical plane. We consider it as okay. So I gave the wrong dimension. This is called H distance, and this is called D distance. Okay. So H is nothing but above or below the horizontal plane. D is nothing but in front of or behind the vertical plane. Vertical plane has only two things. Either it can be in front of vertical plane or behind the vertical plane. Okay. So if I place any object here at a certain distance of H, a certain distance of D, so H is positive and D is positive. Okay. So in the first quadrant, both are positive. H and D both are positive. If you see the second quadrant, what happens is the D will be negative. The D will be negative and H will be positive. Height is positive and it will be behind the vertical plane, so it is negative. Similarly, if you take the third angle projection, the H will be negative. This is my H distance. H distance is negative and D distance is also negative. Both are negative in the third angle projection. If I see the fourth angle projection, in the fourth angle projection, the letter D is positive. The letter D is positive and H is negative. Okay. Similarly, like this, if this is a horizontal plane, anything above horizontal plane is positive. Anything below horizontal plane is negative. Similarly, if I consider this as my vertical plane or letter D, so anything in front of vertical plane is positive. Anything in front of vertical plane is positive, and anything behind the vertical plane, note. So in this note, I have explained that. So a line joining top view and front view is called always perpendicular XY. And in the first quadrant, VP and HP are non-transparent, so that you can see the shadow here. In the second one, in the second quadrant, observer will be here. In order to see the object, this should be transparent. Both should be transparent. In order to see the vertical plane will be transparent, and this one will be transparent in order to see the object shape. In the third quadrant, both HP and VP are transparent in order to see the object. In the fourth quadrant, this is non-transparent and this is non-transparent in order to see. And this horizontal plane rotate clockwise. This horizontal plane rotate clockwise in order to see the object. And the line joining front view, horizontal plane and vertical plane is called XY line. And if you want to see the side view, this is my side view. If I want to see the side view passes through the X1 line. This is my X1 line, and this is Y1 line. Okay, X1, Y1 line, it has to move. Okay. And this is my point A. if I want to project my point A in the vertical plane, it is projected as small letter A dash. Front view or vertical plane, it will project as A dash. In the top view, it will project as small letter A. And similarly in the side view, it is projected as A double dash. This thing you have to remember. This is a capital letter A. This capital letter A will be projected in the front view as small letter A dash. In the top view as small letter A. In the side view it as small letter A double dash. Okay. Front view is also called as elevation. In some of the problems, they call show the elevation view. They will ask, or else they will ask show the plan. Plan is nothing but the top view. This is my top view. Top view is plan and front view is elevation. Side view is directly called as side view. Okay. So front view you have to represent as A dash, small. Top view you have to represent as A. Side view you have to represent as A double dash. Okay. And this is your observer will be having the eyesight with respect to the horizontal plane, and these are the views. If you are only first quadrant and third quadrant, both are at different, you have to rotate clockwise. So he can see this is my XY line. On top of my XY line, I can see this shape, and I need to project the lines. I need to project these lines, and these lines I need to project. So instead of this one at a certain distance, this is my one more circle and this is one more circle. So with respect to XY, this is my positive H. This is my positive D. Okay, whatever may be this distance is positive D. And what is the, and height? Height is considered as H. Height is considered as H, and the bottom. So observer will be looking at this side, and this is the vertical distance is the H distance, and the horizontal distance. Suppose it is the circle is at this side, then it will be D equal to 0. But the circle is at a certain distance. This is called D is positive, and this glass is at certain height from the ground, and this vertical height is called H. Okay. So if you look at this case, whatever may be this height from the ground is called H distance, and whatever may be this distance in front, how much is the in front distance, this is called D distance. We are zero. Okay, already discussed in the last class. So this is my point A. If I project my point A, it will become as A dash in the front view, and the top view it will become as small letter A. And whatever may be this distance I am rotating in the clockwise direction. So whatever may be this distance with respect to the XY, this is my vertical distance you have to draw. So already I have shared the video, watch that video once. So this is my, how to draw it, draw a XY line. First draw this XY line. Mark a center O. From the center O, give H distance. Suppose H is 10, 20, 25, depend upon the problem. Mark it as A dash. And below mark it as letter A, and give the distance as D. And this distance is H. So you can see what is meant by H distance and D distance. H is nothing but the distance above or below of the point HP. So this is above H. And D is nothing but in front of or behind. This is in front, this is behind. So in front it is at a distance of D distance. So this D is positive here. So here H and D is positive. Okay. So this is your first angle projection, and front view will be above XY line and top view will be below XY line. Okay. And okay. So next is the second angle projection. In the second angle projection, observer will be here, and in order to see this one, this object should be, this VP and HP will be transparent, and it will overlap with each other, and front view, top view overlaps with each other in this second quadrant. So that's the reason we don't use second angle projection. So this is a letter B, capital letter B, projected as B dash on the VP, and B on the HP, and depending upon the H and D distance, whether H may be high or D may be high. With respect to D distance, you will get top view. With respect to H distance, you will get the front view. So you have to write B dash for the H distance and B for the D distance. Okay. Next is the third angle projection. In the third angle projection, object is placed here and the observer will be here. And the observer will be here. So in order to see what are the object shape, if he has to see, so we'll be rotating this in the clockwise direction. So the top view will be above and front view will be below in the third angle projection. So when we are rotating, the D distance will be above XY line and H will be below XY line. D is nothing but the top view, so you have to write small letter. H is nothing but the front view, so you have to write C dash on this one. Okay. And in the fourth angle projection, observer will be with respect to this eye side, and in order to see both the things, vertical plane cannot be rotated. So what we do is we rotate this in the clockwise direction. We rotate. Yeah, so if you see the fourth quadrant, in this fourth quadrant, what happens is, so in the fourth quadrant, what happens is the H is below XY line, H is negative, so it will be below XY line, and D is positive, so it will be below XY line, because the point is below XY line, so it will be below XY line in this case. So whenever we are representing the front view or elevation, it should be A dash. If the letter is A, it should be A dash. If the letter is suppose T, letter T, then front view should be T, small t dash. Top view should be small letter T, and the side view should be small letter T double dash. These things you have to remember. Okay. And H will be above, D will be below. Whenever D is positive, D will be below XY line. And whenever H is positive, H will be above XY line. And in the third quadrant, H is negative and D is negative. Since H is negative, it will come below XY line in the third quadrant, because first and third quadrant are totally opposite. And next is the second quadrant. In the second quadrant, H is positive and D is negative. Whenever the D is negative, it will come above XY line. Okay. And in the fourth quadrant, H is negative. So whenever the H is negative, it will come below XY line. And whenever the D is positive, it will come below XY line. Okay. So this is my XY line. With respect to XY line, this is my first quadrant, second quadrant, third quadrant, fourth quadrant. This you have to remember. Okay. And one more thing is profile plane. And one more thing is the profile plane. Okay. So if you see the profile plane, this profile plane is nothing but to get the side view. So suppose this is my letter A. Letter A is a point. So this point is projected as A dash in the front view, or on the vertical plane, it will project as A dash. On the HP or on the top view, it will projected as, on my top view, to project as small letter A. On the side view, it should be projected as A double dash. It should be projected. Okay.